Hello everyone, in this video we see how the LR0 parser work. So first we see the rules. So first rule is augmented the grammar and number it. Augment the grammar and number it. Now next rule is draw the DFA of the grammar. Draw DFA. Now third, parsing table. And fourth is stack implementation. And the last is parse tree. So we see how these rules are follow in LR0 parser by considering one example. So the example is like E read BB and B read CB or D. Now first step is augmented the grammar. So how it is do? First, now the starting symbol is E. Then consider E dash read E. Whatever the starting symbol, if yes read something is the starting symbol, then yes dash read S. Now for this grammar, E dash read E, because the starting symbol is E and the number is 0 for this. Second, E read BB, numbering is 1. Now B, so B read two symbols, this first one and second one. So B read CB is the second grammar and B read D is the third one. So in this way we number it. First see the starting symbol and do this E dash read E, then the grammar as it is right. One by one only consider one grammar with one symbols. If OR is the condition, then write this OR condition separately in below and number it sequentially. Start with 0, 0, 1, 2, 3. Now next step, draw the DFA. Now see carefully how we draw the DFA. So for drawing the DFA, we start from starting, and here E dash read E. So before E write one dot. So now dot E, same as it is, only we draw extra dot. Now this E dot E. Now dot E is present, so we write the grammar of E. So E read BB. So dot BB. Now dot come before the non-terminal. So write all the grammar of the non-terminal. So B read dot CB and B read dot D. Now dot C, the grammar of C is not present, so we write as it is. If the grammar of C is present and it comes before the dot is come before the C, then we write here the grammar of C also. But now in case C is not present, so we stop here. But in case, now here we stop here dot D. D is the terminal and dot is come before the terminal, so we not consider again before the case. But in case the B read dot E, the dot E is the non-terminal, then again we write all the grammar of E in below of this. So this is the rule. So this is our first state, we name it as I0. This is the first state. Now we move forward. Now first we check one by one all the grammar. So first is E dash dot E. So we write now next state is this E. Now we replace this dot, we change the position of dot after the E, so that's why E, and this E dash now read E dot, and this is the one state. And now we stop here because this is the end of the grammar, but here no any variable is also present, so that's why we stop here. And how we draw this condition with the help of the E, so that's why we write here E, and this is our first state. It is zero state, it is first state, so I1. Now next, this is the completed. Now we move here, E read dot BB. Now we shift this dot with respect to this B, so right here B, and this E read B dot B, only we change one position of the dot. Now this dot is followed by B, which is the non-terminal. If the dot is followed by non-terminal, then all the grammar with respect to that non-terminal write in below of the grammar. So now all the grammar of B we write here. So B read CB, or you write here or and then write D, or separately you write directly B read D. This you write this separately also and combinedly this in this form also, but I write separately. And this dot not forgot, write the dot. Now this is the next state, and this is our I2 state. Now this is also we visit one by one. Now we come here third, so we visit third state. So this is dot CB, so we change this with respect to, or we say that this is not the C, this is the opening bracket, this opening bracket, we change with respect to this opening bracket. So now the grammar is B read opening bracket dot B, we change one position ahead. Now wait, now this dot is followed by non-terminal. If the dot is followed by non-terminal, then write all the grammar of the non-terminal. So again the grammar of the B in our original grammar is B read CB and B read D. So write B read CB and dot is come here, and B read dot D, and this is the state, which is I3 state. Now we visit here also. Now last D, so this is changed with respect to D, so B read D dot. Now this B is changed with respect to D, so that's why we write here D, and this is the I4 state. And we stop here, we not further elaborate this term I4 because we end the string here. When the dot is present at the end of the grammar, that time we stop that condition. Now again we start with now I1, I2, I3 and I4, because from this I0 state we visit all the grammar one by one. These all are the completed. Now we come here I1 condition. So I1 condition is also our completed because we reach at the end of the grammar, so we not further explore this term. Now I2 term. So I2 term, again we first start with this grammar. So E read B dot B, so we move this B further with respect to B. So we write here, this is changed with respect to B. E read B dot. Now the dot is present at the end of the grammar, so is any grammar we write below of this grammar? No, because after the dot nothing is present, so we stop itself here, and this is our I5 state. Now the second condition, B read dot CB. Now we move this dot one point ahead here. So now the condition is changes with respect to opening bracket. So what we get here, like this, B changes with C dot B, then all the, now this B is come before the, after the dot. So all the grammar with respect to B, now we write here B read what is the grammar, CB, so dot CB, then B read dot D. So if you see carefully, then all the things are present here itself. So instead of writing one more state, we directly shift this state here. So this is change with respect to opening bracket. If where we are here, we see the grammar B read dot CB. So we want to shift this dot ahead of the opening bracket, and if we do this, then the same grammar we get here. This dot is shifted here, then C dot B, then the non-terminal is present after the dot. So all the grammar of the non-terminal we write below, and all these things are present here itself. So we will not repeat write the things, we only shift the arrow with respect to arrow opening bracket. Now we come here B, now this, so also this. Now if we want to shift this dot ahead, then what how it is work, B read D and dot, and which is already present here. So instead of writing double state, we shift this arrow here, and this is with respect to D. In same I4 condition we get. Now next we completed all the things from the I2 also. Now we come for the I3. Now I3, start with first grammar here, B read C B dot. So for this we change with respect to B. So B, then the grammar is B read opening bracket B dot. Now again anything we write in below? No, because of dot is present at the end of the grammar. So this is the one state, and this is our I6 state. Now this B read dot CB. Now again same, if we change this dot with respect to this opening bracket, then what how the condition is work, B read C dot means opening bracket dot B, then dot B means all the grammar of the B we write below. Same condition we get like this, and if this is the condition, then we here itself follow the loop. Means if this is the condition, then you work here itself with respect to this opening bracket. So no need to write double any extra state, because same, if we change this dot with respect to opening bracket, then we get dot opening bracket dot B, then B is all the grammar we write in below. So we create the loop here, and this now we visited here also. Now we come here, so B read dot D. Now same condition here, B, if we want to change this dot, then B read D dot, and which is already present here. So only we shift the arrow with respect to D. So all the condition, this is also now completed. Now here next state, so this is also already completed because the dot is present at the end. This is also completed. So our whole the grammar we visit one by one all the state and check our grammar is completed or not. Now this is final DFA. Now next step, parsing table. Now see how we draw the parsing table. Now how we draw the parsing table. So we vertically write all the state. So how many state we get? So here in this example, total we get I6, means 6 state present here. So write all the state one by one. So I0, I1, I2, I3, I4, I5, I6, and horizontally what we write, all the terminals and non-terminals. So first we write all the terminals. So what are the terminals? This opening bracket and D. These are the terminals, and non-terminal is E and B. So first we draw write all the terminals. So opening bracket and D, and one more dollar is must in any parser tree or input string everywhere. So dollar we write extra, and now these only two terminals are present in our grammar, opening bracket and D, and now non-terminals is E and B. So non-terminal E and B. So this is the format of the table. Now one by one we see. So now we check same like the previous parser. If you remember, then I not check in opening bracket, I not check in D, I not check in dollar, I not check in E, B, same, but in our DFA. So now I not change, I not with respect to E, we go for I1 state. Or if you want to go the sequence like this, then check I not and dollar. So I not changes with dollar, we go to the I3 state. So if I3 state, so that time we write here S3 state, means shift 3. Here the number of the state is I3, so instead of writing I3 we write S3, because that time we perform the shift operation, and that's why we write S3. Now next symbol is D. So we check where the D is go from the I0 state. So I0 state change the D with respect to I4. So now same, we not write I4, we write S4. So S4. Now I0 and dollar. I0 and dollar is not present, so we not consider. Now I0 and E. I0 changes this E with respect to I1. So now this is the E is the non-terminal, so we not here write S1. This is the condition only for the terminals. So opening bracket and D are the terminals, that's why we write S3 and S4. But this is the non-terminal, means capital letter, and when capital letter is come, then that time only write the numbering. So here 1, I1 is present, so only we write 1, not S1 or I1, only 1 we write 1. Now I0 and B. So I0 and B, we go to the I2, and this is the non-terminal, capital letter, so only we write 2, not S2 or I2, only 2. So 2. Now I1 and opening bracket. So I1 and opening bracket. So I0 not changes in not explore any symbol, terminal or not terminal. We stop in this state itself, and this is the first state after the I0. So that time we say that this is the acceptance state. So we write here I0 and dollar accept, because here we accept this string. Here this is the first state, means the starting symbol is accepted here. So that's why in the dollar we write this is the acceptance state of the starting symbol. So I0 and dollar accepted, because no symbol is outgoing from this state. Here I0 outgoing is E, B, dollar D, but from this we not know anything is outgoing, so we stop here. Now I2 and opening bracket, I2 and opening bracket. So we go for the I3. So now this opening bracket is terminal, so we write S3. S3. Now I2 and D. So I2 transfer this D2 to I4. So we write here S4 because this is the terminal. So S4. Now next, I2 and dollar. We not consider dollar because we not accepted here string, because our string is more further explore more. So we not consider this dollar here for the I2. Now I2 and B. So I2 transfer this B to I5 and B is the non-terminal. So we write only 5. This is the capital letter. So only we write I2 and B is 5. Now I2 and E is remaining. So I2 and E. But if we see, then from the I2 not E is transfer anywhere. So here null is present, nothing we write. Now I3 and opening bracket. I3 and opening bracket. So we transfer this in I3 itself. So this is the terminal. So we write S3. See the difference between terminals and non-terminals. Here all the terminals are present. So for that we write S1, S3, S5. But these are the non-terminals. That's why we write here only numbering of the state, not any S1, I2, I3, S3. So now dollar is also not come I2 because dollar means accepted and not we accepted anything in I3. Now I2 and dollar is complete. Now here I3 and opening bracket. So I3 and opening bracket we transfer in I3 itself. So S3. Now I3 and D. I3 and D. From this D is transferred in I4. So S4. S4. I3 and dollar. So I3 is not accepted state. So we not consider this. Now I3 and E. I3 and E. So from this E is not transfer anywhere. So we not consider this. Now I3 and B. I3 and B. I3 transfer B to the I6. And I6 means I3 and B is 6. Now again I4. So I4 and opening bracket. So I4. So it is also acceptance state. Nothing is go outside, come inside. So this is the acceptance state. So for this acceptance state we write reduce. So reduce means R. Now this is I4. So we write R4 because this is the acceptance state. So we write R4 in whole the terminals, means here also R4 because this is the I4th state. R4. Sorry, not the like this. This is the acceptance state of B read D. And now from B read D, from the grammar, from the numbering, where is the B read D is present? At the 3 number. For this grammar we give numbering 3. So we write R3, not R4. R3. R3. This is R3 and here also R3 because this is the acceptance state. And this grammar is present at the 3rd number of the grammar. Now I5. So I5 is also acceptance state. And this grammar E read BB present here at the 1. So this is the acceptance state. We write R1 because this grammar is present here and the numbering is 1. So R1. So write R1, R1, R1. Now I6. I6. So I6 is also acceptance state. And this grammar B read CB. B read CB. The numbering is 2. So we write R2. So here we write R2, R2, R2. And here E and B we not write anything. Only we write for the terminals. So this is our complete parsing table. I hope you get the idea how we write the parsing table. Now stack implementation means the input. We see the input, how the input is accepted. So stack implementation. So for that we consider the column same, stack input and action. Now stack. So as I mentioned, we consider first input. The input is always given in your exam, so you not consider. Now we put here as a string is CCDD. This is the string. We see this is accepted or not. And after this string we always write the dollar symbol, and the starting of the stack always we write the dollar symbol. Let's suppose here is the dollar symbol, here is the dollar symbol, and here we write the action. So our stack is our grammar is start from 0th state. So we write here 0. This is our starting numbering for the grammar 0. So we start from 0. So we write 0. Now we see 0 in C. Here the 0 is nothing but I0 state. This 0 is nothing but I0 state. So I0 state we look for the opening bracket. So in table, where is the table? Here. So I0 state in opening bracket, I0 state in opening bracket S3. We perform S3. S3 is nothing but the shifter. So shift, what we shift? This opening bracket. So opening bracket shifter with S3. I hope all you get the idea. First we see, we consider dollars as a stack, starting stack. We start from 0. The 0 is nothing but I0. We see I0 for the dollar symbol opening bracket. So I0 opening bracket is S3. So S3 is nothing but the shift operator. Shift S3. So we read shift C, read S3. So now we write this S3. So dollar 0, and now shift this opening bracket here, and the numbering is 3. So always the stack is end with number here in this case. So for our simplicity or for our check the correctness, always this stack in LR parsing end with number. So dollar 0. Now we shift this opening bracket, and the shift is 3. So that's why we write 3. Now this remaining string as it is, opening bracket DD. Now this 3 is nothing but I3. Now I3 and opening bracket, I3 and opening bracket is S3. So S3 means shifter. So shifter, again this is the opening bracket with S3. Now this S3, so this dollar 0 C3, and we shift this C opening bracket, and the shifting is 3. So S3. Now remaining D dollar as it is. Now this 3 and D. 3 means I3 and D. So I3 and D is S4, means shift S4. So shift this D with S4. So now dollar 0 C3 and D with S4. So D and 4, this 4. Now this remaining yes D and dollar. Now next this 4 means I4 and D. This 4 is nothing but I4 and D is R3, means reduce. So the action is reduce. How we reduce? This I4 and D is R3. Reduce R3, so we reduce, but 3. So in our grammar, see where the 3 is present. Here is the 3 present, and the grammar is B read D. So we reduce this, B read D. So we reduce B read D. So we reduce this D with B. So when you reduce, then for one variable we reduce one variable and one number. So we consider both as a 1. So we want to reduce one variable, means we reduce one variable like this, B and D and 4. This is the one variable and number. And for what we reduce, B is reduced. So $0 C3 and B. This D is reduced by B. So B. And now see, this 3 means I3 check it for B. So I3 check for B is 6. So number right here 6, because as I mentioned, always the stack is completed with the number. So 6. I hope all you get the idea how we perform the shift and reduce operation. First, the stack is start with 0. We consider one variable. We check I0 for the opening bracket. I0 and opening bracket is S3. S3 is nothing but the shift. So we shift this opening bracket with S3. So this shift means we shift this opening bracket here. The numbering is 3. Then 3 and opening bracket same. Then we reach here, the reduce operation, where we see this 3. Here 4 means I4 and D. I4 and D, here reduce operation is present. The reduce operation is for the third variable, third number. So we check this R3 means 3 in our grammar. So 3 is for the B read D. So we put this grammar for the reduction here, B read D. Then this one variable we reduce means one character and one number we reduce. This complete makes one variable. So we reduce this D4 and this D4 is reduced for B. So we write B as it is. Now we check this I3 and B. I3 and B is 6. Number is 6. So we write number 6. Now this remaining D dollar as it is. Now we check I6 and D. I6 and D is R2. If R2, reduce R2 means we check the grammar of number 2. So the grammar at the numbering 2 is B read CB. B read CB. This is the reduce. Now here 2 character we want to reduce. So 2 character, how we reduce? One number, one character means one variable. One number, one character means one variable. So these 2 variables we reduce here by this 1 and second. Total 4 we reduce for the 2 variables, 1 and 2. Now the next stack is now C3, this as it is. And now hold the things we reduce for the B. So write B. Now this 3 means I3 check for B. I3 check for B is 6. So numbering is 6. Now this D dollar as it is. Now again check C and D means I6 and D. I6 and D is R2 means reduction 2. 2 is B read CB. So reduce B read CB. Again this is 2 variable. So 2 variables means this is 1 variable, this is 2 variable. Total 4 character we delete from here. one number, one character, one number, one character. This is for 1, this is for 2. Now remaining is dollar and 0, and for this what we reduce this? For the B. So write this B. Now the stack want number at the top, so for that 0 we check for B, is I0 and B is 2, so write here 2. Now this D dollar as it is. Now 2 and D, I2 and D, I2 and D is S4, means shift a S4. So shift this D with S4. So we shift this $0 B2, and now shift this D with number 4, and here only dollar is present. Now check 4 and dollar, I4 with dollar, I4 with dollar, I4 with dollar is R3. So we check, this is the reduction, so we reduce for the third grammar. So the third grammar is B reduce D. So reduce B, read D, reduce B, read D. This is the one character, so we reduce one character here like this, one character and one variable. $0 B2, and for this we write B. So B. Now we want number, so I2 read B, I2, and B is 5, so we write 5 here, and dollar. Now 5 and dollar, I5 and dollar, I5 and dollar is R1. R1 means reduce 1, so 1 is numbering for the EBB, so reduce B, read BB. Now here 2 characters is present, so how we cancel it? Reduce by 1 and 2. For the 2 variable we write cancel 2 variable and 2 numbers, so 1 and 2. Now $0, and for this we write B, because this is the production of B, and number we want now. So 0 read B means I0 and B, I0 and B is 2, so 2. Here we made some mistake, here reduce E with BB. If we check here 1, so reduce EBB, not BBB, EBB. So here not B, here E. This once again I say, we here we reduce EBB, so for that 1 and 2 we cancel. Now this $0 and 0 we write as it is. For this whole we write E, and we want number, so we check I0 and E. So I0 and E is 1, so we write number 1 here. Now 1 means I1 and dollar, so I1 and dollar is accepted, so the string is accepted. I hope all you get the idea about how we shift and reduce anything. If any doubt, please let me know in the comment box. We move for the last phase, means we draw the tree, parsing tree. Now we draw the parsing tree for the string. Opening bracket, D, D. This is our input string. So let's we draw. How we draw? By using our actions which we perform here. So we move from the downward. So first E read BB, and as we know E is the starting symbol of our grammar. So E read BB, then B read D. We only see the terminals. So this is the one grammar, this is one grammar, this is the small d. This is not the non-terminal, this is the terminal. Now we not consider this. Then again B, 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 and yes, enough. So this actions we consider only when we draw the parsing tree. So let's start. So first EBB, this is the first grammar which we perform in the action EBB. So let's E B B. Now next grammar is B read D. So we want D at the right side, so we consider this D and this change with D. Now after this grammar BCB, so this B now C, or we say opening bracket, anything as you want like. So C and B or opening bracket or B. Now next grammar, so we consider this. Now we come here, B read CB. So this B again read C or opening bracket and D. C and what? B. So B. So we now consider this also. This 4 grammar we consider 1, 2, 3 and 4. Now fifth one is B read D. So B read D. And if we see, then we get same in output, C C D D, C C D D, or opening bracket D D, opening bracket D D. So that's why this action is play important role for draw the parsing tree. So I hope all you get the idea how this parser is work. If any doubt or any query, then let me know in the comment box. Thank you.